All right. Hi, I'm Ruben. This is Ashrita and Vineet, and we were working on the problem, you can move to the next slide, of building a model that can predict if a Stack Overflow post is going to be open or closed by moderator. And a quick note on why this is an important problem is that right now we are in the peak of Web 2.0, which means that most of the internet is user-generated. And the problem with user-generated content is that you don't have any guarantees on the quality of the data. So we rely on a lot of manual moderation. And if we are able to automate this process, that's a huge step forward on the internet because it will allow us to have a lot more guarantees on the quality of the data, especially Stack Overflow questions when the solution or the question is completely irrelevant to what you're asking for. The second thing is, one more thing on that, on the importance of the problem is that problem of predicting whether a Stack Overflow question is going to remain open or closed is actually solving many other problems indirectly. Because to predict if a question is going to be closed or not, you need to know if it's relevant, if the question is ambiguous, if it's too specific, it's too general. So you're indirectly solving all of those problems by predicting if it's going to be open or closed. So our basic hypothesis, while there was already a lot of work on this is a Kaggle competition, and there were 161 submissions. The best performing submission was a TF-IDF, which makes sense because it's not a very new competition. But our hypothesis was that a high-capacity model such as BERT, if pre-trained on a large domain-independent corpus, and then fine-tuned on a domain-dependent corpus, which is Stack Overflow, and in an unsupervised way, and then finally further fine-tuned in a supervised manner, because getting supervised labels is a little bit difficult, should outperform the models by a large margin. So our dataset consists of the Kaggle dataset, which is 3 million Stack Overflow posts. Each post is classified as open or closed, and each closed post also includes a sub-classification of the reason why it was closed. While that was great, 3 million is great, high-capacity models need a lot more data, so we found unsupervised data set of 17 million Stack Overflow posts which do not have the accompanying supervised labels. We can move on. So before we go into what our model looked like, the baseline implementation was a TF-IDF-based implementation, and I won't go into details of that because of time limitations, but it essentially is a bag of words model, which means that it does not really account for the actual order of words inside the document, which is obviously a big deal because if I give you a Stack Overflow post, jumble all the words together and I expect you to predict if it's going to be open or closed is a very difficult task, and these don't perform very well. So the BERT model is, at its core, it relies on the transformer architecture, which is very famous now, and it's a transformer architecture has shown a lot of success recently, and it's at its core, it's basically an attention-based mechanism. But I won't talk too much about transformer. The main innovations of BERT is that it introduces a bidirectional training process, which means that it performs training both in the forward direction of reading a sentence as well as the back. So it can establish correlations between sentences in the forward, between tokens in the sentences, both in the forward and the backward, which is not how humans read a sentence, but it shows a lot of success. And while BERT is great, we did not use BERT, we used Albert, which is a light BERT, because as students, we do not have the computational resources or the money to train a gigantic BERT model with a lot of epochs. So the light BERT introduces a few innovations where it shares the weights between layers, and so that reduces the size of the model, reduces the amount of data samples that you need for training. So it's a lot less computation, and it also has a few other innovations like reducing the coherence between sentences, so that it's basically, it introduces a self-supervised factor into the loss, so you need a lot less data for training. So the Ablation Study. So this is the final thing that actually is testing if our hypothesis is actually true or not. How much time do we have? Okay, so I'll start with the last one. We started with the last one, which is starting with a warm Albert model, which means that the weights of the model are trained by Google on a gigantic data set on a large but it has nothing to do with Stack Overflow. And why we made a lot of progress with Google Colab. They kept killing our instance, and so we then tried to set it up on our own. That was showing 60 hours of training time. And so we basically realized we cannot finish training this model. So we downsampled. So for the last one, we trained on 1.75 million Stack Overflow posts. We got a 96% accuracy, and which is great, especially if you consider that Stack Overflow moderators are not rational. So I doubt you'll be able to get significantly better than that. But the ablation study was downsampled with 120,000 records. And sorry, just one more thing on that. The main thing is from 73 to 83%, the only difference is where we perform unsupervised pre-training. And that is evidence that the unsupervised pre-training does help the model. We're skipping everything about our implementation, but you get the point. Thank you.